Alright, the next set of problems, I have three zeros, -2, 1, 3. If I look for x equaling 0, that's 2 times -1 times -3, that's positive 6. This behaves like x cubed, so that's how x cubed look like. I notice the zeros are 1 on each of those, so here it's going to look like a straight line. Here, it has to go through that point, it's going to look like a straight line. And here it's going to look like a straight line. There it is. What if I square the first piece? Well, the zeros don't change. The 0 is -2, a 1, and a 3. So, if I put x equals 0, I'll get 4 times -1 times -3, which is a 12. And if I multiply those out, x squared times x is x to the 4th. The graph looks something like this. And I'm going to assume that's 12. The graph left to right, this 0 has a multiplicity 2. I need to make that look like a parabola. And do you see here, it has to go through that intercept. That's a 1, so straight down. And that's a 1, so when you circle, try to make it as straight as possible. And that will give you a good feel of what the graph look like. What if I squared the second piece? Well, the zeros don't change. That's still -2, 0. That's still 1, 0. And that's still 3, 0. If I look at those, the x-intercept 2 times 1 times -3 is -6, so it's on the bottom. That's all that matters. When I multiply those, x times x squared times x is x to the 4th. So it's going to behave like this. Left to right, this 0 is right there. The multiplicity is 1. That means it's going to cross like a straight line, go through that point. It's going to run up to this. Now, do you notice the multiplicity for this is a 2? That means you need to make that look like a parabola, a smooth curve. I'm shrinking the scale, that's why it looks really sharp, but normally it's very smooth. Here we go. And do we agree that this is a power of 1, so it has to look like a straight line? There it is. Here, -2 again, a 1. Oh, that's the same thing. Okay, this one we did right there. That's okay. I can't rearrange it, otherwise I lose a lot of time and space. Let's go for this one. This is a -2. This is a 1. And this is a 3. And if I put 0 in for x, that's a 2 times -1 times +9. That's -18. You really should mark those just to make sure that you're getting the right graph. This behaves like x to the 4th, so still it's going to look like that. Left to right, that 0 has a multiplicity 1, which means a straight line, sort of. It's going to go through this point, a curve. And do we agree that this 0 is right there and the multiplicity is 1, which means it's going to straight up? Now, do you see that this 0 is right there and the multiplicity is 2? So we know this is going to look like a parabola and make that a smooth curve, and there's the graph. What if I look at this example? 0 at -2, 0 at 1, and 0 at 3. If I put 0 in for x, 4 times 1 times -3 is -12. Let's say that's -12. If I multiply those out, x squared times x is x to the 5th. So x to the 5th looks something like this, left to right. This 0 is right there. The multiplicity is 2. I need to make that look like a parabola. Here it's a parabola. It has to go through that point. If I look at the negative 1, the 1 is multiplicity 2. I need to make that look like a parabola right there. That's how a parabola look like. And it has to turn, and isn't that a power of 1? So it's like a straight line. There it is. If I look at this function, negative 2 negative 1, negative 2, 1 and 3. If x equals 0, 4 times negative 1 times 9 is negative 36. If I multiply those out, x squared times x squared times x is x to the 5th. Left to right, this 0 has a multiplicity of 2. I need to make that look like a parabola. There it is. That's what it looks like. It's going to cross through this point. It's going to run up. Now, when I look at the 1 has multiplicity of 1, that means it's going to shoot straight up like a straight line. And the last piece, do we see that this has multiplicity 2? I need to make that look like a parabola. And there it is. Now, there's no telling how high this will go or how low this will go. That's okay. We just have to match those intercepts and the end behavior and the multiplicities. This has a negative 2 right there, a 1 right there, and a 3 right there. The first 0, the second 0, and the third 0. I notice they're all multiplicity 2. Do you see that? All what I need is the end behavior. If I multiply, first if I put 0 in, I'll get a 4 times 1 times 9, 36. It's positive. It's very important. If I multiply those all, x squared times x squared times x squared is x to the 6. So since they're all multiplicity 2, I know it's going to look like a parabola around the first 0. This is going to go through the intercept, and I know it's going to look like a parabola because it's multiplicity 2, and through the third intercept, and it's going to look like a parabola. There is no way of having a power of 2 and not looking like a parabola. It must. What if I cube one of them? Well, let's see. Negative 2, 0, 1, 0, and 3, 0. X equals 0. I'll get 8 times 3, 24. Positive. If I multiply those out, x cubed times x is x to the 5th. I notice this is the only cube. The rest are both the same. They have a power of 1. So the cube, I know how to make this a cube since the end behavior points this way. So a cubic looks like this really. So I could adjust that. And the rest is going to look like straight lines. Just run like a straight line across it, and a straight line across it. And there it is. This has a 0 at negative 2. This has a 0 at 1. And this has a 0 at 3. X equals 0. You get 8 times 1 times negative 3, negative 24. You mark that at negative 24. When you multiply those out, x cubed times x squared times x is x to the 6. X to the 6 looks something like this. I notice this is a cube, and I notice this is a square. So I need to make this look like a cube. Well, a cube, since it's going to point upwards, I'm going to make it a bit more flat. So, oops, it didn't work. So a cube looks, nope, still. There we go. That looks more like a cube. So get rid of this and maybe even bend it a bit more. So there we go. Perfect. It's going to go through the intercept, no way around it. It's going to run and hit this. That's multiplicity 2. That means I have to make it look like a parabola. And here we have multiplicity 1, just go straight through it, and that adjusts the turning. Here, negative 2, negative 1, negative 2, 1, there's 1, and 3, 2, 3. Actually, yeah, that's okay. No, the last one, let me expand it properly. So look, if arm curve, negative 2, negative 1, negative 2. 1, 1 is right there. 3, 3 is right there. If x equals 0, I'll get 8 times negative 1, that's negative 8 times negative 27. 8 times negative 27. 8 times 27. That is 56. 16. 216. When I multiply this out, that's like x to the 9. X to the 9 is like x cubed. Do you notice the multiplicity on that is a 3? The multiplicity on that is a 3. And the multiplicity on that is a 3. That means I need to make cubics. Since I know what the left endpoint look like, that's how a cubic look like. We have a problem. That intercept is not matching. Let's double check. That's 2 cubed, that's 8. That's negative 1. And that's a negative 27. That's a positive 216. That's why that point is very important, so that you wouldn't make a mistake and give me the wrong graph. So I'll take this out and I'll say, well, look, now that this looks like a cubic, I know that make it look like a cubic, and it has to go through that point. And since they're all cubics, when this comes down, to make this look like a cubic, that's what cubics look like. So I do that ahead of time. And to make that look like a cubic, I'm going to erase this. I know it's going to open upwards, but a cubic looks something like this. And there it is. Now we go to the book. And the book, we're looking at page 284. This is what they have. They say, find all the zeros, if any, of each function and state the multiplicity. I'm adding, you're going to graph those for me as well. You're graphing everything in this section. So, x equals 0, x equal 2, and x equal negative 7. If I put x equals 0, I'll get 0, so it's right there. If I multiply those, x to the 5th, x to the 8th, x to the 9. Doesn't x to the 9 look like a cubic? Left to right. This has power of 1, like a straight line. It must pass through the intercept. Do you see this point has multiplicity 5, like a cubic? How would you make that look like a cubic? Well, you would erase this part, and you say a cubic, since it's going to come from the left, a cubic looks something like this. So make that. There we go. And a power of x squared, 2. Isn't 2 multiplicity 3? So I need to make that look like a cubic. I know how to do that too. And look at that. I'm getting those graphs in no time. There we go. How high does this go? We can't figure that. Only calculus students do that. And that point as well. How about this problem? So here, multiplicity 5, multiplicity 3. And that's what we're shown in the graph. Here, we have 0. We have 4. And we have negative 9. Left to right, this is 0, 0, and it behaves like negative x 4, 8, 9. Something like this. Well, left to right, the first 0 is right there. It has a multiplicity 1. That means it's going to cross this down. And it has to go toward the intercept. Now, do you see this 0 is multiplicity 4? That means it's going to look like a parabola. Well, now it looks like a parabola. And if I look at the 4, The 4 is right there, has multiplicity 4. That means it's going to look like a parabola as well. There you go. There's the graph. I got the zeros. Negative 9, 0, and 4. Multiplicity 4, multiplicity 4, multiplicity 1. So not only are we going to list the multiplicities, we're going to graph them. How about this? 0 at 0. Negative 6. And negative 3. 0 gives me 0, okay? And this behaves like x to the 6, x to the 7, x to the 11. X to the 11 is like a cubic. There we go. Left to right. This 0 is right there. That's a multiplicity 1. That means we're going to try to make this as a straight line. Now, this is right there, has a multiplicity of 4. So I'm going to make that look like a parabola. There we go. And x equals 0 has multiplicity 6. Also, I'm going to make that look like a parabola. And there it is. And what if they give us a problem like this? Well, I will say factor, and that's going to be the rest of the chapter. Factoring all of those. That's going to be 5x into x minus 3 squared. That's why multiplicity is so important. 0, 3, right? And this behaves like x to the third. Left to right. This 0 is right there. Multiplicity 1, that means it's going to cross straight. And this 0 is right there. Multiplicity 2, that means a parabola. There we go. This problem, if I factor 2x squared out, I'll get x squared minus 4x minus 12. That is 2x squared into x minus 6 into x plus 2. The zeros are 0, negative 2, and 6. Left to right, this behaves like x to the fourth. Left to right, the first 0 is right there, multiplicity 1, it crosses. That's 0 right there, multiplicity 2. I need to make it look like a parabola. And this 0 is right there, multiplicity 1. I need to make it like a straight line. A straight line, something like this. There we go. Number 22, I factor that. That is 3x to the fourth into x squared plus 2x minus divided by 3. 3 divides 7 2 times. You have 12 left over, 26. Is that right? 360, 72. Okay. And that is 3x to the fourth into x. Something's not right. Let me check. 3x to the fourth. 6 divided, that's a 2. And 72 divided by 3. 3 divides 7 2 times. You have 12 or 24. 24. Got it. Okay. So that is x plus 6, x minus 4. And what do you notice? 0, negative 6, and 4. This behaves like x to the 6. Left to right, this 0 is right there. It has a multiplicity 1. It crosses. This 0 is right there, has multiplicity 4. I need it to look like a parabola. And the last 0 is a straight line because that's multiplicity 1. And how about 24 and 26? x equal 5, x equal negative 3. If I put 0 in, I'll get 25 times 3, which is 75. This behaves like x squared times x cubed. Left to right, this 0 is right there, has multiplicity. Nope, messed up. This 0 is right there, x equal negative 3, multiplicity 1, it crosses. And this 0 has multiplicity 2, so I need to make that look like a parabola. There we go. And the last problem, x equal 3. These are a bit, there aren't that many of those, just a couple. This can never equal 0, so you ignore completely. You just look at this as if it's y equal x to the x minus 3 squared, except if you put 0 for x, you will get 9 times 9, which is 81. And doesn't this parabola open up? So we assume the graph doesn't look like this, but we're going to assume that. Your homework on page 284, 1 through 25 odd, follow directions. On top of that, you're going to graph numbers 11 through 21 for me. And that takes care of this section.